What were I doing? Blood spill management hypochlorite ke साथ था. Those were halogens, iodine and chlorine. Sorted. Now I come to oxidizing agents, which is very, very essential. We have H2O2, peracetic acid, and plasma sterilization. I think H2O2 we've studied a lot in medicine, in path. We know it is such an important and a dangerous thing. Free radical injury karata hai. We know it is a strong oxidizer, right? Please note, for effective concentration, we have 3 to 6%. For spores, we need a 10%. So obviously, spores ke liye we will always need something extra. What all can kill the spores? I will tell you right at the end. Okay? Other than H2O2, we have peracetic acid, which is very, very effective. Even less than 1% can kill the spores. So that is important. And now comes the question that you're going to get. Plasma sterilization or STERAD. Plasma sterilization or STERAD. That is very, very important. Let me show you a STERAD. Guys, this is a STERAD. So nothing you will find out of it. It is a closed white color ka machine. Okay, so now before I begin, I have told you that this is going to utilize some oxidizing agent. So you know what is it going to utilize? It is going to utilize H2O2. So listen to every word about plasma. Did you ever wonder? So I've got, I know it's looking like a cluttered slide. I wanted everything over here in one slide because aisa bullet question aisa shoot hone wala in plasma sterilization into you. So plasma, what is plasma? Plasma doesn't mean blood wala plasma. Plasma is what you used to study in school. What are the 3 states of matter? Solid, liquid, gas, right? 3 states of matter. Then we used to say that there is a 4th state of matter, plasma, and that is nothing but contains ions and electrons. Yaad aa raha hai? Kuch you used to study in physics, chemistry in your school. 4th state of matter is plasma. So you'll say, ma'am, now I've understood why this is important, because you're doing such experimental things. You are creating 4th state of matter. How should I create 4th state of matter? And why is that machine looking like such a closed white box? Because inside it, I have to make sure of, as I said, question shooting to you. You have to make sure it is closed because you have to maintain vacuum. Guys, if ions and electrons se deal kar rahe ho, to you will have to keep vacuum and you will have to keep a low temperature. These two are very famous questions. And what will you do? You are going to add H2O2 to it, and from H2O2 you will create that 4th state of matter using UV photons. You will use UV photons, and from this you will create something called plasma. Plasma is the 4th state of matter, but to do this you have to have 2 things: vacuum and low temperature. Why low temperature? I'll tell you in a while. Because maybe all the things which are sensitive to heat, jo heat se problem hai, those you can sterilize over here. Now going back, I realize it's a short process, 75 minutes mein ho jayega. And do you think you're gonna get any toxic products harmful for the patient or the environment? No, there are no toxic products. It's a short duration. Overall, it's very good. I can use surgical instruments, and I told you some very important 2 things or 2 scopes. I told you there is something called as arthroscopes, and then I told you something called urethroscopes. Remember, I told you all the bronchoscope, endoscope, ye sara scope was what? Glutaraldehyde, Sidex. Scope was from Sidex, but these arthroscopes and urethroscopes are coming out with plasma sterilization. What is the control? It is Bacillus stero-thermophilus. Where else have I studied it? Bacillus stero-thermophilus. Number 1, I studied it in autoclave, and number 2, I'm going to study it as a control in plasma sterilization. So we will make a final table in the end, don't worry. Okay, but this is your basic as of now, and this is the machine. So if they give you this machine and they ask you what will you sterilize under it, I'm telling you again and again, ye question aayega. Arthroscopes and urethroscopes are sterilized here. All the other scope things that we were doing, those were going under Sidex. Whatever XYZ scope you were doing, bronchoscope, laryngoscope, wo Sidex mein jayega. Are you clear with plasma sterilization? Because plasma was the 4th state of matter. Thoda niche aate. Let us come to the 3rd state of matter, and that is gas sterilization. Which gas am I talking about? I'm talking about ETO, ethylene oxide. Okay. So firstly, ye kya karta hai? This is going to kill the bacteria and kill the spores. It is microbicidal, sporicidal, it will kill everything. But now you need to compare this gas sterilization versus the 4th state of matter, that is plasma sterilization. So tell me something, in plasma sterilization, did you have any toxic products in the end? Nahi na, kuch nahi tha, you said safe. But look at the ethylene oxide. Ethylene oxide ka to toxicity is not stopping only. Ethylene oxide is inflammable, irritant, explosive. Now they've started saying that, so basically you can see over here it's going to catch fire. It's going to explode. They're also saying it might be carcinogenic. So they said never ever use 100%. You are supposed to mix it with some inert gases. You mix it with some inert gases. Earlier they used to say 10% tak dilute kar lo, so you can use 10%. Now they say no, not even 10%. Roughly somewhere around a 3% or 4% is enough. Rest of it you mix it with inert gases because it's very dangerous. So one advantage is it's got a lot of toxic products, whereas plasma sterilization did not have any toxic products. Second, plasma sterilization I told you was 75 minutes, matlab short time. The cycle was of a very short time, whereas ethylene oxide ka cycle dekho, it's almost taking up to 1 day. There is a long time of the cycle to go on. So definitely there's another disadvantage coming up my way over here. Also, there are a lot of other factors. You have to maintain the concentration of ethylene oxide, the humidity, the temperature. So a lot of parameters. Matlab gas sterilization is a headache that I'm having. I have to take care of all these factors. It is going to take a lot of time. Along with that, it has so many toxicity products. So it's a big headache. Plasma sterilization that way is shorter with no toxic products. यूज कहाँ करेंगे? Where do we use this such a dangerous, or you can say such a complicated thing? You're gonna use it for primarily for cardiopulmonary machines. Cardiopulmonary machines, and you can also keep pre-packed syringes under it. What is the control? The control is Bacillus globigi. Bacillus globigi, G for G. So gas sterilization के लिए Bacillus globigi. Let me tell you, Bacillus globigi is nothing but Bacillus subtilis का थोड़ा सा kid. Bacillus subtilis का आगे का family, that is globigi. But most of the books have eliminated this part and said it is Bacillus globigi. So we will learn G for G. It is going to be sterilization for gas sterilization, control for gas sterilization. ठीक है, should we move forward? Plasma done, gas done. Moving on. So the next that we have to know are going to be the heavy metal salts. So something like silver nitrate, silver sulfadiazine, mercury. I think I've given the answers. So for ophthalmia neonatorum or neonatal conjunctivitis, what is the Creed method? I think you must have read that in ophthalmology. The Creed's method tells you that we use 1 to 2% of silver nitrate, isn't it? Haven't you read about it? That there is instillation of 1 to 2% of silver nitrate for ophthalmia neonatorum. Then we have something called silver sulfadiazine creams. So these are basically used for burns patient. All your Bernol and all these creams that we have, they have silver sulfadiazine. And in anti-serum vaccines, next time you see a vaccine, turn karna, you will see that in the end there is something called mercury that is written in the form of thiomersal. Thiomersal or mercury is written, and that can also act as a sterilization method. So basically heavy metal salts are also utilized. Next we go on to what? We go on to the surface acting agents. Surface acting agents mein what do we have? We have something, see, surface acting matlab they are gonna do something to the surface tension, hai na? So they are going to lower the surface tension for us. They will lower the surface tension. Either they can work as a detergent soap type of a thing, and that is known as anionic. So please note, all the soaps that we use, obviously jinka detergent wala action hota hai, they are not going to kill everything na. Soaps, if soaps could kill everything, why would we need other things? So soaps have a weak microbicidal activity. They have antimicrobial activity, very weak, but you should know their action is said to be anionic. So simple, anionic is what? Anionic is said to be the detergent like activity. That is what is anionic. Then what is cationic? Now listen to all the KKK that we will be doing. Cationic are nothing but the quaternary ammonium compounds. An example iska aega cetrimide. Cetrimide, I think you all know. SS, I had told you cetrimide is what you have in Savlon. So repeating, when they are talking about cationic, always remember that iske andar C wala example aega, that is cetrimide, and K wala quaternary ammonium compounds. Then you have something called non-ionic, which is useless. And then you have something called amphoteric. Ampho word always means two things together. So these are known as two things together. These are known as TIGO compounds. And two things together means that they are going to have the action of anionic also and cationic also. So they are going to have both activities. Made they are going to have the detergent activity also and the killing the bacteria activity also. So remember, anionic ka main activity kya tha? Detergent activity. Cationic ka activity kya tha? That was going to kill the gram positive and gram negative. Gram positive a little more. So now amphoteric says that I am going to take the detergent activity of anionic and I am going to kill the activity of killing the bacteria for cationic cationic. So both these activities I will take and I will become 2 activities wala TIGO ya amphoteric, and 2 activities wala compound is used in teeth wale procedures. What did I say? 2 activities wala TIGO compound is used in teeth wala procedures. Okay? So remember, TIGO anionic plus cationic, teeth procedures means all the dental procedures will prefer to use your amphoteric properties. Is that okay? Coming to the next one and the last one, actually, the dyes. This you don't have to know in too much of detail, but I'll read it out for you. I'll tell you, but then I'll tell you that one question which will help you always. There are aniline dyes which are more active against gram-positive. There are acridine dyes also that are more active against gram-positive. So aniline dyes, I'll give you some examples. All of you have heard of malachite green, crystal violet, then gentian violet. Ye sare violet and malachite green pada hai na? These aniline dyes can kill many of the gram-positive organisms but not active against TB. ये वाला point याद रखो. Have you all heard of what is the culture media for TB that you have? What culture do you use? You use the LJ media. And if you've seen the LJ medium bottle ka background is always green. Why? Because LJ media has malachite green. I have utilized the property from here only. I know malachite green will be able to damage all the other gram-positive organisms, but will it allow the TB to grow? Yes, it has allowed TB. TB is allowed to grow, no one else is allowed to grow, and that is what I want. I want LJ media for the growth of TB, and malachite green is solving that purpose. Not only is it allowing TB to grow, but all the others have been told, okay, you can't grow. So all these gram-positives are stopped. That is why in Lowenstein-Jensen media we use malachite green, that is aniline dye. Similarly, we have acridine dyes, and they further have an advantage is that they can act in presence of organic waste like soil, feces. In that presence also acridine dyes can work, and they have acridine, acriflavin, proflavin. These are the kind of names that you have here. Flavin jo dyes hoti hain, these are the acriflavin, proflavin, these are the acridine dyes. So you've done a lot of chemicals starting from alcohol, aldehydes, plasma, gas sterilization, oxidizing agents, heavy metals, dyes, so many of them you've done. But I want to ask you a basic question. If I give you any 1-2 ml of a solution and I say this is a solution labeled X, can you tell me, is this a good disinfectant or not? Chemical X, you remember Chemical X in Powerpuff Girls, as a scientist tha, Chemical X ke saath he used to play and he used to do different experiments. We are going to become that. So Chemical X we will take and we will say, and we will ask you, is this a good disinfectant? You will say, ma'am, hang on, I will have to do 4 tests. For testing a disinfectant, I will have to do 4 tests, and let me start. Number 1, phenol coefficient test or Riedel-Walker test. So if I take, what I'll do, I'll take a broth of Salmonella typhi. I'll take a broth of Salmonella typhi and I'll say if this can kill Salmonella typhi, to acha hai. If it cannot kill Salmonella typhi, then it is bad. So how do I compare? I know that phenol will be able to kill Salmonella typhi. Phenol, though, is I know phenol, Lysol, Cresol, phenol, I know they can kill Salmonella typhi. I know phenol can kill, so I will compare this solution X with phenol. I will see which is the dilution at which solution X has killed Salmonella typhi divided by the dilution at which phenol has killed Salmonella typhi. If it comes out to be more than 1, this means pass. Solution X has been passed. But what is the disadvantage? You have done the testing with only Salmonella typhi. You do not know the efficacy in organic matter. You do not know the efficacy with organic matter. How will this solution X react in feces, in soil, in yeast? How will it react? I have no idea. I have only tested it with Salmonella typhi, but that is not enough. So this is known as the phenol coefficient test or the Riedel-Walker test, and the name only tells me that phenol ke saath you are comparing. Phenol coefficient should come more than 1, then it is passed. But what is the disadvantage? You have not tested it with organic matter. So this Riedel-Walker test will now require a modification. So what is modified Riedel-Walker test? Has some modern names, Chick and Martin. Okay, some modern names I have added in this modified Riedel-Walker test. Riedel and Walker had become very purana naam. I added Chick and Martin into it. Now this is gonna basically test the disinfectant in the presence of organic matter. So this is an advancement in the presence of organic matter. So for example, you can have yeast, you can use it in the presence of soil, in the presence of feces. So you've done real ground reality check of this particular solution X. Now pass ho gaya. That is modified Riedel-Walker-Chick-Martin test. Now there are two more tests. There is something known as Kelsey-Sykes. पहले दोनों का नाम देखो. One is Kelsey-Sykes test and one is going to be Kelsey-Maurer test. So Kelsey is the same. One is going to be Sykes and one is going to be Maurer. So remember Sykes में you have K coming. So Sykes is the capacity test, and Maurer में you have the U coming, so that is going to be the in use test. Repeating, what is Kelsey and Sykes test? The capacity. You will say, ma'am, solution X तो pass हो गया. Solution X has been passed, but I'll say it has been passed one time by one test. If I'll put load on top of it, how many times will it work? That you don't know. So if I tell you to read one page, and you say that page in front of me as it is, I'll say, wow, what a memory. But when I'll give you 100 pages to read, then how much will you retain? That is what I'm trying to guess. If I give you too much of load, how will you react? So remember, what is the Kelsey and Sykes test? When you are trying to see the disinfectant ka use with increasing microbiological load. So you're trying to test its capacity. Ke kitna capacity hai? Like I'm trying to test your capacity, that how much of microbio can you read? Right? So when you're trying to test for capacity, that is the Kelsey-Sykes test, versus what is Kelsey-Maurer test? It is the in-use test. This is basically what we say is that once you are using a disinfectant, you are just thinking from that point of view that disinfectant will go and will clean the surface. But can the disinfectant also end up getting contaminated? So basically this is done to test for the contamination of the disinfectant. This is done to test for the contamination of the disinfectant. And in fact, also one more thing that they say about the in-use test is that this also tells you reality in use. So if you say that, ma'am, ab to bahut zyada you have told us to study a lot of things, now my real test will be the day I go and sit in the exam. How many marks will I get? How much will I recall? What will I write in my answer sheets? So basically when you're talking about the reality, so please note, for the reality testing, that is known as in use में कैसा act होगा, that is in use test. So I think we've done all four. Quickly we'll revise. The first one was phenol coefficient test, Riedel-Walker test. You were only doing comparison with phenol, not a good thing because you were not testing any organic matter. So now you're going to use organic matter like yeast, soil and feces, and that is known as modified Riedel-Walker test. Modern naam, Chick and Martin. Then you have two Kelseys, Kelsey-Sykes, Kelsey-Maurer. Kelsey-Sykes, Sykes के अंदर K आया तो capacity, how much capacity does it have, and Kelsey-Maurer has a use, so that is known as the in-use test. Yes, we have finished off the testing of the disinfectants. Now I have 2-3 tables to show you, which is a summary that I'm trying to make. So let's start off and tell you, in the decreasing order of resistance, you see a huge list in front of you, which is very, very scary, I agree. But this much you know, that the most resistant always has to be prions. So you know what books have done? Books ने ना बीच में skip कर दिया है. Not books, but many other sources, they have not given you the entire list. So prions है, after that they have said हाँ spores है, then they've said some cyst, some TB, some virus, some bacteria, फिर से virus, फिर से bacteria, बस ऐसे कर दिया. That will never ever give you any concept. That will not even make you understand anything, and neither will you be able to solve questions. So difficult तो है, but if you give it a little bit of time, nothing is impossible. So now what do I have to see over here? रटना पड़ेगा. So ma'am, let me go back to my help of mnemonics. तो कहाँ से start करें? Let me see that how did my journey start? Physics, chemistry, bio. That is how my journey starts. And physics, chemistry, bio लिया था, and then I realized गए, life में गए. So physics, chemistry, bio में गए. Let us begin. So what is this physics, chemistry? Physics, chemistry, bio में गए. Physics means, so P, C, B, M, G. P for prions, C for Cryptosporidium oocyst, B for bacterial spores, M for, of course, there's one organism, Mycobacteria. G से कौन सा parasite याद आता है? Giardia. Remember, prion, Cryptosporidium, bacterial spores, Mycobacteria, Giardia cyst. Okay, physics, chemistry, bio में गए. ओके तो गए तो क्या हुआ सो यू दैट नाउ व्हेन यू थिंक बैक यू विल से मैम फिजिक्स केम बायो तो वाज जस्ट अ छोटा सा सब्जेक्ट नाउ कम टू नीट पीजी द रियल प्राइज इन लाइफ इज नीट पीजी फिजिक्स केम बायो एंड 12th बोर्ड्स वर जस्ट स्मॉल ट्रॉफी छोटा सा ट्रॉफी तो स्मॉल ट्रॉफी में अच्छा नहीं करा स्मॉल ट्रॉफी नहीं नेवर माइंड बट फाइनल लार्ज प्राइज वन द फाइनल लार्ज प्राइज वन इज गोना बी द फाइनल नीट पीजी डन एमडी डिग्री मिल गया तो स्मॉल ट्रॉफी नहीं स्मॉल मतलब जो स्मॉल नॉन एनवेलप्ड वायरसेस है ट्रोफोजोइड्स एंड नहीं मतलब ग्राम नेगेटिव बैक्टीरिया सिंपल सो द वर्ड इज ऑल्सो टेलिंग यू स्मॉल वायरसेस नॉन एनवेलप्ड वाले ट्रॉफी फॉर ट्रोफोजोइड्स नहीं फॉर नेगेटिव सो ग्राम नेगेटिव सो स्मॉल ट्रॉफी आई एम नॉट इंटरेस्टेड इन फाइनल लार्ज प्राइज वन फाइनल मतलब ऑल द फंगल ऑर्गेनिजम्स large of course refers to the large viruses non enveloped P refers to now of course positive gram positive bacteria and one for virus कौन सा virus बचा the enveloped viruses are basically gonna be the most susceptible the enveloped viruses you are saying in the decreasing order of resistance so this means these were the most resistant and these were going to be the least resistant so मतलब you will say मैम enveloped virus को kill करना इतना easy exactly इतना easy why so easy because you will study this concept in virology envelope is made up of something to do with lipid and as soon as you will put any antiseptic any alcohol any disinfectant lipid to will dissolve this envelope is going to dissolve out it's very easy to dissolve out an envelope that is the reason that enveloped viruses are the easiest to kill that is why just by hand washing properly and using a hand sanitizer enveloped viruses are going to be killed easily they are the least resistant matlab easily can be killed I know this is still a tough list I agree थोड़ा सा 3 times repeat you will be done once I will repeat with you physics chemistry bio में गए तो स्मॉल ट्रॉफी तो नहीं मिली स्मॉल ट्रॉफी नहीं नेवर माइंड फाइनल लार्ज प्राइज नीट पीजी विल बी वन प्रायॉन्स क्रिप्टोस्पोरिडियम बैक्टीरियल स्पोर्स माइकोबैक्टीरियम टीबी जियार्डिया स्मॉल नॉन एनवेलप्ड ट्रॉफी फॉर ट्रोफोजॉइड्स नहीं फॉर नेगेटिव final for fungus large for large non-enveloped prize for gram positive and one for enveloped virus okay now we come to the next thing and that is known as the Spalding classification something again which was formulated I think many decades ago but is still coming in MCQs they say that we have divided devices into 3 types critical device is what critical device is the one that will go inside our body like some catheters or some endoscopes or bronchoscope something that is penetrating into the body in some way or some machine that is said to be a critical device on the other hand semi-critical is something that will just come in contact with mucous membrane maybe something to do with one of the something with which you are examining the mouth or anything that is coming in contact with the mucous membrane even some of the scopes are used only for mucous membrane analysis fine so critical are those which will penetrate into the body semi-critical are those which are only going to come in contact with mucous membrane and non-critical devices will be those जो सिर्फ skin के साथ contact में आएंगे right so now this is how you divide the 3 devices in any OT something going in the body very critical device so you will have to disinfect it not just disinfection you will have to do sterilization you will say I will have to use chemical sterilant I will have to use chemical sterilant that is CS chemical sterilant use karna padega because this is going inside my body for a semi critical device also something going in your mucous membrane there also you will have to use a high level disinfectant for a non-critical device which is only coming in contact with your skin you can do with an intermediate or a low level disinfectant so simple if something is penetrating you will need the highest level possible chemical sterilant use karoge semi critical high level se ho jayega and non critical you will use for the intermediate and low level disinfectants these were all devices now I come to what about non critical surfaces don't you have so many surfaces tables chairs computer screens printers and the slabs on which the samples are collected so many surfaces are there in a hospital in a ward in an OT what do you do with those so remember for non critical surfaces we prefer to use a low level disinfectant Okay, so now what I want to show you is an entire table which I've tried to, I've got this from one of the most high-end journals of micro that we have. This is not supposed to be learnt as it is. My basic concern over here is that which are the ones which can act on the spores. So, two tables हैं. Which are the ones which are able to kill the spores, and which are the ones which will not be able to work in organic matter. If there is organic matter, they will get inactivated. So, definitely something we have to think of over here. So before that, you will say, ma'am, spores ke liye, can you tell me like one table so that I don't have to learn each one individually? Yes, what are the sporicidal agents that we have in the body? So EFGH, apt. It's a very chota sa mnemonic. EFGH, apt, PPPT. So E is what? Ethylene oxide. Of course, gas sterilization to काफी toxic था. It will kill the spores. Formaldehyde, glutaraldehyde. Yes, they will also do. H for H2O2. Of course, H2O2 is the same thing that was used in plasma sterilization, and H2O2 was an oxidizing agent. Peracetic acid is also an oxidizing agent. Okay, then I said that we had glutaraldehyde, so that was Sidex. Remember, there was something also called OPA Sidex. So with that I have learned the ophthalic acid also. Okay, what else with H? We have hot air oven, sodium hypochlorite, and hot air oven हो रहा है तो A से autoclave भी होगा, that can also kill the spores. Finally, if you remember tyndallization, out of boiling and tyndallization, both were done at 100 degree, but tyndallization could kill the spores. So try to group up things. Gas sterilization, okay, formaldehyde and glutaraldehyde. Then you have the H2O2. H2O2 is the same thing that you use in plasma sterilization also. Then you have hot air oven and hypochlorite. Hot air oven है तो उसका साथ में autoclave भी लगा दो. Then you have something called peracetic acid, and you have the P or ophthalic acid. T for tyndallization. All of these will kill the spores. So now coming to, tell me this guys, will all the EFG, formaldehyde, glutaraldehyde, will they kill the spores? Yes. EFGH, H2O2, will it kill the spores? Yes. Chlorine, hypochlorite, yes, hypochlorite could also kill the spores. For everything else I have written negative, negative, negative. So sporicidal ho gaya na, EFGH and APPPT. These are the sporicidal agents. Now we come to the ones that are inactivated by the organic matter. So pehle to please start differentiating them. All these that could somewhat kill the spores, is it right to put them in a high level disinfectant or a chemical sterilant? Yes, because they can kill the spores. So glutaraldehyde, formaldehyde, H2O2 and hypochlorite. EFGH में से formaldehyde, glutaraldehyde and H2O2 and hypochlorite, तो ये 3-4 चीजें, these are gonna be high level or chemical sterilants. Why? Because they can all kill the spores. After that, so if they can kill the spores, then I'm not telling you that they of course can kill everything else. ये तो common sense हो गया. Now we come to, after the high level, we'll come to intermediate level. तो intermediate level में एक तो ये alcohol आ रहा है. Number 1, what else is coming? Alcohol, phenol and iodophores. Alcohol, phenol and iodophores come under intermediate level disinfectants, and these were not able to kill the spores. That is why they are coming under intermediate level. Finally, coming to everything else, the chlorhexidine, the quaternary ammonium compounds, ये जो soap and all these things were there, these were all low level. So simple, जो spore को kill करेगा, that will come under high level. Alcohol, that is isopropyl alcohol, and then iodophore and phenol. These are all intermediate levels, and baki sab come under low level. Finally, coming to which are the ones that might get inactivated with organic matter. Again, a matter of big debate, because there are, kya hota hai that sometimes you will say that, ma'am, you told me that this gets inactivated with organic matter, and there I read that aisa nahi hai. Because concentrations matter, preparations matter, what material are you testing, that matters. So there's a lot of variation in this chapter, and that is the reason that students are having so much of a problem. So please note that the ones which are inactivated on organic matter are the 2 aldehydes, that is glutaraldehyde and formaldehyde, and phenol. So remember these, glutaraldehyde, formaldehyde and phenol, they are inactivated on organic matter. Coming all the way back, I hope you were able to remember that all this is based on the fact that जो spore को kill कर देगा वो highest level का है, chemical sterilant. But what is even more resistant than the spores is going to be the prions. So now my next question out here to you guys is, how do you treat for prions? What are you going to do for prions? So prions ke liye there are a lot of methods that have been mentioned, but I'll give you the basic that we have for the inactivation. So whatever device, prion, if you study in virology ke end mein I have covered, and you have also covered in pathology, prions is something that can spread via neurosurgeries, right? So if you have anything that has come in contact with the brain while doing a surgical instrument or any kind of surgical instrument, that obviously is a critical device. Now it went in the body, penetrated in the body, the critical device. What you can do, you can place it in whatever that surgical instrument is. First you treat it with one normal NaOH, right? Or you can do an autoclave of 121 degrees centigrade for 30 minutes, or you can also do 134 degrees centigrade for 1.5 hours. There are two very varying kind of proportions that are mentioned. So ya to you are going to basically put it in one normal NaOH, then you're going to do an autoclave for 121 degrees centigrade for 30 minutes, or they are saying you directly do an autoclave of 134 degree for 1.5 hours, and then after that you can carry out whatever routine sterilization you had thought. You said that I had thought I'll sterilize this product by this method. So whatever routine sterilization you had thought of, you are going to go ahead with it. So there are a lot of protocols, and despite following all of these also, sometimes they say that it is very difficult to kill prions. So one of the school of thought says that, pehle autoclave ka usual batao. Autoclave ka usual you say 121 degree for 15 minutes. They are saying either you can only increase the timing to 30 minutes, or you can, sometimes they are saying you have to increase the timing and the temperature, both 134 degree to 1.5 hour, and you can also use a chemical called one normal NaOH. So after a lot of mix and match, you come down to doing the routine sterilization, and that is how you're going to kill the prions. And that is how finally this entire chapter comes to an end. Quickly tell me, which of the following test is used for testing the capacity of a disinfectant? So please note, capacity, Kelse, Sykes is for the capacity. If I would have said in use test, you would have tested Kelse, Morer. Next one, glutaraldehyde is used for all except glutaraldehyde was Cydex, scope, proctoscope, endoscope, bronchoscope. What is it not used for? Thermometer. Thermometer ke liye kya hai? It is isopropyl alcohol. Next one, control for ethylene oxide. Ethylene is a gas, G for G. What is it going to be? Bacillus globigi. Last question, what is this machine? Remember, plasma sterilization. This means this machine is a sterad. You have to tell me all are true except, let's start. Produces less toxic products like ETO? Yes. Does it use Bacillus stereothermophilus as control? Yes. Is it utilized for the sterilization of products which are heat sensitive? Yes, because I know that sterilization was done, this one was done at low temperature, correct? And the chamber that is used for carrying out uses ambient air? No, plasma was the fourth state of matter. Ions and photons are being used. I cannot use ambient air. I told you that we need to have a vacuum. So this is the false statement, and that is the answer over here.